Hi everyone, welcome to part 2 of Challenging Themes in Topography. The topic that we are going to discuss today is identification of landforms. Identification of landforms on topographical maps are done with the help of contours. Contours are lines that connects places located at same elevation. And there are few characteristics of contours which we should know. This includes the spacing between the contours and the corresponding slope of the land. Closely spaced contours indicate a steep slope, whereas widely spaced contour indicates gentle slope. There are a few more things which we will learn in the coming slides. And as per the syllabus, there are 6 different types of landforms that needs to be identified with the help of their contours. These are steep slope, gentle slope, hill, valley, ridge or water divide, and escarpment. To identify the landforms, we should be familiar with the landform first. So let us go through a set of photos which gives us an idea about all these different landforms. These are 6 different landforms given in the syllabus, and the first one here is a steep slope. The slope on the left side of the screen is very steep. Such slopes are indicated by contours by drawing the contours very close to each other. We will learn this later. Now, this image shows a comparatively gentle slope. Slope is, or the gradient is comparatively very low. Next landform is a conical hill or a hill. Here, height of the feature is increasing towards the center and it has approximate conical shape. Next one is valley. Valleys are low-lying areas between two highlands. Next one is ridge or water divide. Ridge or water divide are not same all the time, but they look similar. Therefore, both of them have same kind of arrangement for the contours. In this diagram, what do we see is a mountain range, and the topmost part of the range, which is shown here is using an yellow line, is what a mountain ridge is. And it is also called a water divide because rivers that originate on either side of this line flows to different drainage basin. There is another name that is drainage divide. Here in this picture, there are two drainage basins, and the line which is separating these two drainage basins is a ridge or a drainage divide or a water divide, or sometimes it is also called a watershed. The black line towards the left side of the diagram is another ridge. Now the last landform is escarpments. Escarpments are sudden droppings in the edge of elevated landforms like plateaus. When the edge of plateaus or any other landform decreases very rapidly in a very short distance, then that is what is called an escarpment or a scarp face. Here in this diagram, we have this shaded areas. These are sharply dropping areas. These are areas where height is dropping very rapidly, and above this, it's a flat area, almost flat, gentle. Then there is a sudden drop in the height. Again, there is flat land further below. There is another diagram which is showing the same thing. We have the scarp face and the elevated area and the low area below that. So this is how escarpments will look like. Identifying landforms with the help of contours. The arrangement of contours helps us to identify the shape of the land. As I told you already, closely spaced contours indicate steep slope and widely spaced contours indicate gentle slope. And to understand this, sometimes we will have to draw cross sections along the contour map. Drawing cross sections of landforms will help us to identify the actual shape of the landform. And to do this, we will take a sample contour map like this. Let's see how we can draw cross section along a line in this contour map. To do this, the first thing is to draw a line across the contour map in such a way that it connects all the contours. Now this is a line. If you observe carefully, you can see that this line is intersecting all the contours. Let's name it as AB. Any name can be given, there is no rule as such. It is better to give a name. Now the next task is to note down the points where line AB is intersecting with all the contours. This green dot here is the first meeting point, At this point, the 100-meter contour is intersecting line AB. Second is this meeting point. Here the 200-meter contour line is intersecting our line AB. Then all the remaining. So this way, first we have to note down all the intersections of these contours with the line that we have drawn. Now the next task is to draw the projection or the shape of the land along this line. For that, we need a coordinate system or a graph paper. Height's highest value is 600, so only that much is needed here. Now in this diagram, the y-axis shows the height and the x-axis is the uh, horizontal spacing of our intersections between contours and lines. That means we are going to place line AB on x-axis. Now for easy understanding, I am using a graph sheet and different colors are used. And if you see that for same height, same color is used here on the top. Yellow dots are at 100 meter height, red is at 200 and so on. Now things are very simple. What we have to do was we have to place these dots on line AB to the x-axis. First thing is placing A over A. A and A should be overlapping, otherwise the point that we took as A should be at the origin of the coordinate system. Then remaining things need to be put in different places according to their height. Let's begin with the first dot, the yellow dot. Yellow dot is at a height of 100 meter. That means when we put this yellow dot on the graph sheet, it should be at a height of 100 meter directly below the point where it is marked right now. So let us drop it down like this. This is the location of the first dot. It is at a height of 100 meter. Now next one is a 200 meter height intersection. It is located in a place and it should be dropped directly below that at a height of 200. Then 300 directly below that. That means we are maintaining the horizontal distance as it is without making any changes, and at the same time we are putting them at different height as per their height. This will be 400 meter, 500 meter, 600 meter. There are two 600 meters nearby. Then 500, height is decreasing toward the other side. 400, 300, 200, and the last one is 100 at 100 meter height directly below its point. Once if we do this, we have the shape of the land. Only thing remaining is connecting these dots using freehand. While connecting, we should make sure that the topmost line is, or the top part where two 600 values are connecting, should not go and touch the next 100 value, 700, because there is no 700 contour here. Highest point is somewhere between 700 and 600. So while connecting that, we should be a little careful, and while connecting the lowest point, it should be between 0 and 100 also. So what we see here is a gentle slope on the left side and a very steep slope on the right side. And this is the shape of the land along line AB. We can draw a line in any manner we want. We can draw a line parallel to AB directly below that. Then also we will get a shape. The shape will be different because shape of the land along that line will only be represented here. Whatever it is, this is how we identify the shape of the land using contours. Now, this is how it is done on a computer screen. Now let's see how do we do this in exam. When it comes to exam, what we have is map, pen, pencil and paper. So how do we do this on a sheet of paper? Let us. Here we have a contour line or a contour diagram. So in order to draw the cross section, I already told you that we have to start with drawing a line across the contour diagram. But when it comes to doing it practically on a sheet of paper, we don't necessarily need to draw a line. Instead, we can use a sheet of paper and we can place it on the contour diagram in such a manner that it cuts all the contour lines. Alright. Now here we can give name. So one end as A, other end as B, or any two names, P, Q, A, B, C, it doesn't matter. This name is not important, but to do it in a proper manner, we can give two endpoints. Now the next task is very simple, just like what we did in the previous one. We have to note all those points where this particular line AB is intersecting with the contours. We have at least 8 intersections. So we need to note down all those intersections and their values. Okay, highest value, the value in the middle is 500 meters.
then from there value is decreasing outward. So let me do it. So this one in the middle, this one as well as this one, these two. Okay, these two are the points where the 500 meter contour line is intersecting our line AB. So we'll just make a note of that. Then next 2 points, this is 400, this is also 400. So 400. Then all the remaining. So we have 300 point here, 200 here, then there is 100. So actually there are 5 lines, sorry, so there are 10 intersections. Similarly on the left side also we have the point where 300 is meeting our line AB, then this is where the 200 contour is meeting our line AB, and next very close to A we have the first 100. So we can just check it. So this is it. So we got the intersections, all the intersections and their values with us, and we have the end points A and B. Okay, so I missed the place where I kept it earlier, but it was somewhere here. So whatever it is, after the completion of the cross section, what I'm going to get is a cross section along this particular line. Okay, line is not drawn there because that is not needed. So imagine this is your topo map. On the topo map you will be placing a small sheet of paper like this and make sure that the edge is straight. Now the next task is to draw the graph. Alright, so for this purpose we will not be actually using a graph sheet. Our aim is to identify the shape of the land. So you are not supposed to, or you don't need to show all this working. Okay, sometimes you will be able to identify the landform even without doing all this work. So this will be a rough work that students will be doing in their answer sheet, in somewhere in the corner of an answer sheet. So a graph sheet is not necessary, and you're not allowed to carry a graph sheet also in the board exam unless it is provided by the board. Now instead of graph sheet we can have a coordinate system like this. We have the x-axis and y-axis. Now let's bring our paper where all those intersections are marked. Make sure the origin and the A is at same point. So A point A and the origin is the same point. Then align the remaining things along the y-axis, sorry, x-axis. Now it's time to note all those intersections to the x-axis. This is the first one, this is 100. Second one is 200. This is third point, 4, 5, 6, that is 500, 400, 300, 200, 100, and B is not compulsorily, but let it be there. So this is point B. Alright, now this spacing should not change. Whatever is the spacing available between each and every point, it should be there as it is. This tells us, or this gives us the actual shape of the land. Now we don't need this at all. We can move this paper. Now we know the value. First is 100, second is 200, next is 300. Now it's very simple. We have to make dots along these lines. At 100 we will make the first dot. First point is of 100 meter side, so directly above this dot at 100 we will put a dot. Alright, second one is of value 200, so directly above this at 200 we will put the next dot. Similarly all the remaining, the third one is 300, so if you want you can use a scale so that you will get exact location. Okay, so this is 300, then this is 400, then this is 500, next one is also 500. Okay, next one is 400, next one is 300, next one is 200, and the 10th point finally is again 100. So we have marked all those 10 dots. Now using freehand technique, just join all these dots. Okay, and this one like this. Now before we connect these 2 points, we have to keep in mind the height is 500. They are not going to 600 meters. Okay, so when we connect these two, we should make sure that the line is somewhere between 500 and 600 meters height. It should not go above 600, because if there is above 600, it's more than 600 height, then definitely there will be another one contour. So here it is not available. That means the height is somewhere between 500 and 600, so it should be like that. And finally, while connecting this end also, it should be between 100 and 0. Here also it should be between 100 and 0. Okay, so now we got the shape of the land. This is how a conical hill or a hill will look like.
That is how we draw cross-section of landforms with the help of paper and pencil. Now let's go and check the arrangement of contours for the remaining landforms. We are not going to draw the cross-section for all the remaining landforms. It's of no use and it will take a lot of time because you have understood the method. Now the thing is that you have to practice it. Let's begin with the diagrams that we have there in the syllabus. Steep slope and gentle slope we have already discussed, and we understood that closely spaced contours indicate steep slope and widely spaced contours indicates gentle slope. Let's take an example from the topographical map that we are going to use. Now, this is the map that we are going to use, and here the contour interval is 20 meters. Height difference between two nearby contours are 20 meters. Look at this contour map or the map extract. The left hand side has closely spaced contours, whereas the right hand side has widely spaced contours. So you must have understood now that the left side is a steep slope and the right side is gentle slope. Next one is a hill or a conical hill. Look at the arrangement of the contours. Contours are circular in nature. They are becoming smaller and smaller as it goes towards the center, but the height is increasing. You can see the shape of the land below that. This is how the arrangement of contours of a conical hill will be given on a map. Let's take an example. Here you can see a map extract with a spot height 542 and the contours around this 542 spot height is circular in nature, approximately circular in nature. And if you follow the values given there, height is decreasing from 542. After a few meters you have, after a few, it must be around 1 kilometer, not one, less than 1 kilometer. We have 400 meter contour. Further ahead, there is 200 meter contour. That means height is decreasing outward from the spot height. So this is a conical hill. The next landform is valley. Look at the arrangement of the contours. It is almost similar to that of the conical hill. Conical hill has circular contour lines. Here they are not completely circular. But see the values. Values are increasing outward. Otherwise, towards the center, values are decreasing. If we draw the shape of the land, the cross section, we will get the shape like this. Look at the middle line, there is 2000 meters of height, and the dot will go at the bottom of the graph sheet. Next one is 2100, so it will be little above that, little outward. Next one is 2200, it will be little above and little outward. And finally, the shape that we are going to get is shape of a valley. Let's take an example from the map. Here, height is not given, only one spot height is visible, but this is actually a small cropped part of map. If we go the outer areas, you will get the values of contour lines. Now, look at the shape of the contour lines. Almost all of them have an approximate shape which is similar to that of the diagram given on the left side, that is this shape. So this is the shape of contours here in this part of the map. Alright, and height, I told you, is decreasing from left and right towards the center, just like in this photo on the left side. So this shows a valley. Not only that, you can see rivers originating from both sides. Rivers are originating from both sides, and they are coming to the middle area and then they are flowing towards the south direction. Alright, and one more thing, you can see a highland also here on the left side. There's a highland. There are two branches of rivers. One is flowing towards the southeast and another set is flowing towards the southwest. In between, the contours are elongated. So that's a mountain ridge. We will learn that in the coming slides. So there's a mountain ridge. Then towards the eastern side, then there is a valley. Again, height is increasing towards the east further. Alright, let's go forward. Next one is a ridge or a water divide. Ridge or water divide have same shape and therefore they have same contour arrangement. Here the topmost part of this region is the mountain range, ridge or the water divide. Shape of the contours are elongated with increase in height towards the center. A reminder, ridge or a water divide is the topmost part of a mountain like this. Alright, and therefore shape of the contours are elongated. Here is an example. There is a beautiful mountain range here running from the northeast to the southwest, a very narrow mountain, and the topmost part or the middlemost part of the mountain is a ridge. This is one ridge, then height is decreasing, then again it is increasing from here. So two mountain ridges are there in this map. Final one is escarpment. Even though the diagram given here is not bright, it is really meaningful and helpful. Look at the values. We will start from the right hand side. Values or the height of the contour is 1200, then it is slowly increasing to 1220, then 1240. Now the same contour is taking a U-turn. So in this area, height is changing very slowly. Otherwise, we can say contours are widely spaced. It's a gently sloping area. In general, height is decreasing from the middle area where the W of widely is written to the southeast. And let's go forward. If we go forward here in this brown colored area, there is a rapid decrease in the height. You can see the contours arranged very close to each other, and within a very short distance, height is decreasing from 1220 to 1060. Further ahead towards the northwest, contours are again widely spaced. So what do we understand here? The eastern side is a gently sloping area, then there is a very sharp reduction in the height, that is the escarpment. Further down, height is again changing very slowly. So in between, somewhere in the middle where the name escarpment is written, has a rapid drop in the height. So this is how these contours in a escarpment region is arranged. Let's try to visualize this shape of the land. So we have brown and black line. The shape of the land here will be somewhat like this. Towards the brown, height is slowly increasing. And after that, in the brown area, where the contours are closely spaced, height is decreasing very rapidly. And that is what the scarp face or the escarpment is. This is a diagram just for you to understand the shape of escarpment. We have an elevated land, and when the edges of the elevated land has a very sharp drop in the height, such scarp faces are called escarpments. Now, this is a map, I mean a part of the map, and one contour with the value is visible here, that is 720 meters. And there the contours are circular in shape, and from here to different direction, contours are spreading little widely. The areas where these three arrows are shown, contours are widely spaced, which means that is relatively a flat area. Alright, if you check the nearby areas of the map, you will understand that height is decreasing from that 720 to outer area. So this area is a relatively flat area, but as we go little outward, then there is closely spaced contours. That means in this area, contours are very close. That means slope is very steep. Further down, if you observe, you can see the contours are again becoming little more wider. So this place where these four arrows are drawn is a vertical drop, or it is an escarpment. Let's see a real-time photo. This is the photo of the Niagara escarpment. Alright, one more time. The top region is almost flat, then there is a rapid decrease in the height, that is escarpment, and finally the bottom again is almost flat. Alright, so this is how escarpments will look like. Now we know how the contours will be arranged. Initially, contours will be widely spaced, then within a very short distance, contours will be very closely spaced and the height will be decreasing. Then further down, again it can be flat or gentle, just like in this photo. So that's it. These are the 6 different types of landforms that we need to identify. I think you will be able to identify the landforms now. And in case if you get confused by seeing the arrangement of the contours, you are not able to guess the shape of the land, you can always go for drawing the cross section. In most of the cases, you don't need to draw the cross section, you will understand the shape of the land. But in case if you have confusion whether it is steep slope or escarpment or something like that, in that case, go for drawing the shape of the land. Then you will understand the shape of the landform or the landform. So that's it from this video. We are winding up. See you in another video with another topic. Thank you.